No, I student here.
Huh?
Yeah, I know. I was a student here.
Yeah.
And get student.
Yeah. So I'm watching the animation of water vapor from the University of Wisconsin website. It's very impressive. Next time maybe I'll show the animation. I just now picked up one about this discussion. This is on 21st July. There's a clear indication of a low water vapor had squeezed between two high water vapor. Okay. I would like to know how it came. I don't understand it. How does the thin layer of low water vapor get squeezed between two high water vapor? And here it is Caroline. Locally, you can see that there will be a break in the rainfall there. So I think if you look at the animation, you see it comes from the southern hemisphere. But I would like to understand how it goes between two high water vapor regimes without getting any diffusion effects and so on. Okay. So I do remember one I didn't fully understand. One of the key experts on atmospheric dynamics is Brian Hoskins. He argued that this kind of, if you do trajectory analysis, your accuracy is very, very good and nobody is doing that. And he claimed various examples. For example, this debate came more than 10 years ago. Satish had launched a balloon and forced a maximum black carbon concentration at a height of about 7 kilometers actually. And they couldn't identify any aircraft passing off that height. And Hoskins argued, I didn't fully understand it, argued that air descending from Pakistan, interestingly, comes over India, it will produce a sharp this one. He says, people don't understand that there are a situation where diffusion doesn't play a role and certain things maintain the trajectory. So this could be that category. So maybe next time I'm showing more animation of this. And it's really interesting how cold, dry air. This is different from what it presented. It's not from up above. It's from below. Okay? Because air is very cold and dry. And that comes and gets squeezed between very moist water vapor in July, when the coast is very moist and Indian Ocean is also very moist. In between, this thing comes. So to me, if you do a little more of these studies and if this reaches somewhere here, then it can be a cause of break. Okay, so this is what analyzing the animation being done by University of Wisconsin. I'm sure you can download the data. I'm not going to do it. You can find out, you can download it. Then you can study a lot of trajectories, find out when such a low water vapor trajectory comes and hits somewhere here, and whether that leads to a situation where rainfall decreases over India. Okay? Because I'm a great believer that water vapor is a trigger for rainfall. Okay, let's come to what's happening here. So as of today, it's remarkable. The total rainfall cumulative is 420 millimeters. Okay, compared to 399. So already we are 21 millimeters above normal. So things are going very nicely. And as you know, we don't understand why. There is a very warm El Nino even going on still. It's not gone away. And except for the little late start in June, July has been doing extremely well. And if you look at this part, July rainfall for country was 15% above normal. Only group which suffered were the Northeast, minus 30%. Central they are 26. South Peninsula, the last 1 week, you can see what has happened. It's gone well above normal. Okay. So we still don't understand why the rainfall in July was so close to being above normal. Now, we have to look further. We have come to the end of the first half of the monsoon. Next week, we get into August. So let's look at my favorite scatter plot, which is June plus July versus August plus September. Okay. The idea is, knowing June plus July, can we say anything about August, September? Okay. Now remember, we're already at 420. So I'm almost sure today is 26, 27, 28, 29, 30, 31, 5 days, averaging 10. You can add another 50, 40, doesn't matter. So we are going to be somewhere here. Okay. So unless something unusual happens, like what happened in 1913 and 2001, where the August September rainfall became very low, Except for that, the impression we get here is that if you're somewhere here in July, your rainfall in August is at least 380, if not 430 and 480 rainfall. So the question is, whether in the next 2 months, will there be a long break which will completely spoil the good news we're having so far? And that's not true. I'll tell you why. You mean I want to look at this figure more closely. All the red points are 21st century. So we started from 1901 to 2022. So we have to get a good color because in 2 digits. But I want to look at these 2002. When only nuclear was poor, water was also poor. Look at 2009, similar value. 2014, all these are last 20 years. 2012. See, these 4 events all belong to 21st century, okay? And the rest of them are on that chapter. This is the thing we don't understand why these 4 years were quite poor both in July and August September. There's some recovery here, but it was not enough to recover. But today, this year we are actually somewhere here. So the chances of a drought is somewhat low, but I would not rule out below normal rainfall, maybe close to what IMD is saying 6%, 7% is still possible. Okay. Now we come to the most puzzling part, which bothers me so much that I think I made an error. So all of you can check whether I made a mistake. Okay. So I looked at the anomaly of rainfall in the 22 days data for July. Okay. And the most interesting part is, of course, for India, rainfall was crazy. And notice that there is a dry patch here. Kerala is getting very good, low rainfall. I'll show you that. The Indian world not this that the rainfall is high over India, but the rainfall is high over Indonesia. Now, this to me is completely counterintuitive. See, when you talk about all this talk about El Nino, water circulation, everybody agrees that during the 3.4 was anomaly, air rises over 3.4, it sinks over Indonesia. Okay, read any paper. This is given as a theorem, the known. Okay, this year it didn't happen, and I don't know why. There is no logic as to why, if the air is so warm here and rising, why is it not sinking over here? Which is what we're all taught. Textbooks, papers, all swear by the fact that water circulation anomaly occurs during El Nino years, and air sinks over Indonesia and rises over this one. And I can give any number of examples of years where it happened. This year is not happening. Now, it's not clear why, because this part, see, India not being affected by water circulation, understandable. So, link between water and circulation outside the tropics is much more complicated. You can talk about IOD even here, you can talk about something else there. But from the equator, the dominant circulation is water. There is no head there. Okay? So we should have a simple theory, and that theory is not working. Okay? The question is why? I think I want you to notice that this year, all the anomalies are occurring around the equator, and off equator it is all positive, including Kerala. Now I want to remind you before I forget that the whole set of papers published about 10-20 years ago, where I forget the name of the person, she's been brought it up. So she argued that defining El Nino through SST is not the right thing. Okay? And she does not intend picked up. It's a very profound idea. She's saying using SST as the criteria for El Nino definition is misleading because an SST anomaly does not always produce a convection anomaly. And so she has written a series of papers in which she defined El Nino through OLR. Okay? OLR with El Nino. Okay? And she shows how it removes a lot of disturbances. Now, I personally am not very happy about it. Why? Because OLR, of course, is an indication of convection. But unfortunately, it's a very noisy variable. So it's not like an SST I like because it has a persistence. SST normally falls positive in July, it will positive in August. It will take some time to cool down. OLR will change from week to week. So I don't know how stable her definition is, but she has a profound point that unless there is anomaly in convection in the atmosphere, El Nino will not work. That is the I'm talking about the teleconnection mode. You can still define El Nino based on SSS, okay. But you want to understand the El Nino teleconnection, you better use OLR as your index. So next week I'll mention those papers. I didn't have it right now. So those papers are worth reading because she redefined El Nino only through convection, not through expansion. Now, why I'm saying all this is because this is what I'm normally used to seeing. This is the correlation between Nino 3.4 and rainfall in the tropics. Okay, this is the classic picture. All of you know it. The correlation, of course, very high here and positive along Nino 3.4 naturally because higher temperature, more rainfall, and so on. And the interesting arm of positive anomaly here, and then just to the just below it, there is a negative correlation, that is drying all the way in Australia, Indonesia, and part of India. So this is the standard El Nino response, and that is not occurring this year. That's the point to figure out why it's not occurring this. Why this kind of thing with correlation shows is the majority response is missing. Now we come to now the same thing. I've done a close up here to highlight the Indonesian part. Same thing. I'm just taking a close of that. Now this one is composite of all the drought years, which are El Nino years, and this is what I call canonical thing. Descent over Indonesia, descent over India, ascent to north of Indonesia, and ascent over the equator. Okay? So this canonical response is not working this way, and I don't have any reason why. This is what this is very anomalous here. This standard response with every El Nino breaks did not come here. You cannot hide behind IOD. IOD is not yet there. So we have to give some explanation what is doing. I'm not able to find, except that I found one thing last evening. I'm not fully understood it. Happening in the southern hemisphere. Okay? The southern hemisphere jet will normally remain somewhere here and move here. But I don't care how that jet moving here will ever be. I don't know. So I'm not studied it. I don't see any paper on it. So that is the only anomaly at all in circulation that was visible the last 3 weeks. Now, one more anomaly is the northward migration. Now, if you look at the omega field, this is the not anomaly, actual value. You see that in the months of June and July, the only thing that happened is north of the equator, if I can find out, there were 2 events hitting northern migration. Right? Nothing occurred on the equator, south of the equator. This is also very rare. Normally, things start south of the equator, where that is that, move all the way to India. I don't see it at all this year, and that also is very peculiar. I don't understand what that's causing. Okay. Yeah, I think this is a repeat. I think I got a couple of. Oh, no, I think this is already covered. Okay. This only want to show you this thing, what's happening here. South of Australia, the jet movement has caused an anomaly in rainfall here. So that is, I'm not fully figured yet. I will say something next week when I say something there. So as far as I can see, the only thing which is unusual this year is the southern hemisphere. Northern hemisphere, there's nothing occurring which can explain the unusual behavior. So all of you can think about it. It's an interesting phenomenon. Now let's look at Kerala. When India is having floods in North India and in Maharashtra and parts of Karnataka, Kerala is mostly deficient. Okay. Now this is a very interesting issue because we did some work a long time ago with my student Rajendran with a Japanese model in which it was clear that due to global warming, the jet shifts about 10 degrees northward. So this year also jet is to the north of the normal position. So the winds in Kerala are lesser than winds in Karnataka and Maharashtra. So the moisture coming to Kerala is less. And this is happening year after year, except 1 year when, of course, Kerala had a flood. We leave aside that particular unusual event. Kerala rainfall has declined for the last 50 years. Okay? Nobody talks about it because Kerala is even a high rainfall. So nobody worries about it. But I'm sure from the point of view of ecology and climatology, it's a serious issue. If over the next 100 years rainfall keeps decreasing, it will have a huge impact on the ecosystem of that area because it used high rainfall. Okay, let me see what's going on in the next few weeks. There is a hint of a break. This is from Q, starting from this is this week. Already the hint that there is going to be a break in a few days, according to this. And next week is completely below normal. Okay? So, so I think there's going to be a break going to come. And one can ask whether the break is related to either dry intrusion or some other phenomena. Can think about that. This is from okay, this model. Okay. Now, you remember this model I had earlier projected. Now, this is based on June init condition. They made a forecast, thank you people, and they showed that August will be below normal. Okay. But they're pretty much July not too good. They are doing high rainfall in Kerala. That didn't happen. And they didn't get spotlight. So that model still has some doubt. But they're saying both August and September will be below normal. Okay? So keep that in mind the next few weeks. What are they saying with the July initial condition? They are changing their mind slightly. September may be normal, but August continues to be below normal. Okay? So this is what we are going to watch out next 1 week. How whether the unusually active phase we had for almost most of July will stop and we'll get into a break phase. And we can ask, looking at the animation done by this concept, we can ask whether attraction of water vapor play some role in it or not. That we can look at. Okay. Now there's also a hint from the CFSV2 forecast that in the next few days it's going to come down. Okay. It is not. I think I got up to today or somebody. I'm sorry. Yeah. This is not right. This forecast is not right. We're getting numbers around this value, around 10 millimeters per day. It is lower than 44 in the 21st and 20th and 23rd, but it has not come down below the kilometer. Now, let's see the next forecast of that. The next forecast is that it is going to go on this board. Let's say next week whether this one comes through or not. There's decline in the rainfall. Okay. Okay, I'll stop there. Any question? And do you remember that person who had different? We discussed that long time. I remember. In one of the Monsoon campaigns, 4 years, 5 years, discussed on this. I have to go look it up. And so if you define according to that criteria, it may not be any of this. So that's the fact. Only is the atmospheric parameter. I'm not very comfortable with it because it will change every few weeks. Like doesn't oscillation. So I think we have good SSD data. Everybody is using it. So it's very noisy. The atmospheric parameter is going every few days fluctuating. So all of that problem. But here's the point that since we not really understood the connection between SSD and OLR in the pressure position, you better use OLR as criteria to understand telemetry. So, but unfortunately, we not have people who read that so that the paper will not get cited. But I think share some new insights with them. I'll mention papers next week and we'll look at that.
The problem is the forecasting.
Huh?
The problem of the forecasting.
Yeah, that's it. What is the issue? So the OLR will consider like radiate from but understanding the connection, I think OLR is much better one than everything. Okay, everybody.
When you say we don't understand why this is happening, mention why rainfall is so high.
Yeah.
But initially, before I remember reading that INP had predicted that this would happen.
Yeah.
So they.
But you know, they didn't tell us why. My problem is that INP is forecast. But
that means the model they're using, they are able to understand what is happening on that issue.
No, that's not discovered. Antibody is not about what. See, INP file they give you is based on the committee representing both the vertical model and the animal model. And they can and second take out how they correct model. That is not that. That's very important. You are getting that from nothing happens. You must not be real thinking of that. So I don't know why they don't accommodate for. They think it is very close to specific and and whatever is not, that's possible. Or you have some other inside we don't have. Or the pollution code gave some, because their final process is dominated by everything in that. They don't trust anyone of them, and that's not possible. Neither is good. So there's a lot of discussion and conclusions are having. That's why it is a protected activity. But from an academic perspective, the reason they give us why that purpose. Because if it's purely with the chemical, then put alcohol, it is that. If it's purely with the physical, it is the other over experience with this. But you know, it is a problem. The reason I think all this because it was earlier, that before the Chairman 2014, 2015 forecast of drought, IMD tended to always give nowadays. And that is based on this concept that 60% of the time, look at the country, right? So that makes it very, I mean, we used to make fun of it, but now that I've learned everything, I won't make fun of it. For example, so the Joseph, one of the most leading forecasters in India, mentioned that when he was in Delhi airport, he has reported the fires. And even if the smallest chance of thunderstorm, he will tell them we have the thunderstorm. They'll come back and offer. I'm saying all this forecast, including the running on the pilot, he told me what was the forecast because both of them not there. But Joseph argued what? I'm a forecaster in the airport. If I say thunderstorm, and if it occurs and there's a big crash, he'll be engaged. About that, how seriously job is very serious. And he told the story, Abhishek recorded it. There was a famous crash in Delhi of matter of near the central line, one of them. And everyone heard the whole story, 1974. And this occurred during a heat wave, not during a thunderstorm. And Joseph was there area for some time. And he was, and you know, when this crash occurred, yeah, international flight. And so when the crash occurred, there are all kinds of conflicting parties involved. One is airport company. They don't want to blame for it. And of course, the airport people who do the airport controller, they are also in this stuff because all the three involved. So, and of course, Indian Airlines. So, fine. So, everyone tried to defend their what is called stuff. So, he told me, before, and before he did a very funny rule. He was trying to stand for 8 hours to stand over the person. No sitting. I don't understand this. He did was very painful. And he said, so we were in better forecasting. How to make shades and predict conditions which may not occur most of the time. So if you make one mistake and the aircraft, we are being paid. So if you understand that environment, then you know why you do it. I didn't know it earlier, so I will make one of them, but now I understand. Forecast scenario, especially for control situation. So your trade state, small example of underground, let's be able to confirm with that. Tomorrow anything happens, nothing. And what is very important, my father was doing aviation a long time ago, and he told me that time, he told me that that crash probably occurred because of a heat wave that is a low pressure in some areas. And the pilot was landing, just arose with that aircraft was dropped. I think it dropped. I think Yamana, it actually crashed in Yamana river bed. So this program in India, that is month of April, May, if you may happen. There is a local heat created low density area. And a pilot who is landing the plane has to allow for that. Like allow for here, similarly allow for the low pressure. And my father felt that these guys did not do that. When they happened about few area from Delhi to Bombay, it crashed near Haveli, Delhi. I don't think that crashed. So this always occurred within May. And I don't know why you do from that well, but global for me that you guys don't know what this is subjected to as what you call an airport technology. So they always make, so certainly, the level of the government, they want to make clear. And studies show that 20-30% of the time, job do not occur. You are better off. There are traditions for a long time. Only in the last 10 years, their confidence in teaching went up. They started making more forecast. But not that if the model output is not giving clear message, it is not. That's logical. So that's what I think. But I mean, somebody would come and let's wait for the season over. I thought some people said that they can come and tell us what exactly made them make that problem. Because to me, these unusual are the ones which teach you normally there is a both, there is nothing to learn. Because one is normal most of the time. But here is the drought and the pressure which will give you some good impact is the phenomenon, which is the main interest for academic. So that's why we have to keep communicating the unusual. So this year I would say the most unusual. All of you can do your own analysis and data as well as you see anything unusual correctly. Because to me, the only thing that can explain the difference between this anywhere, all the here, something in the circulation regime is different from the previous year. Otherwise, the normal things would have happened, right? So we are not able to figure out what it is. And it remains surprised because this is why I feel very guilty. Because 20 years ago, I could have blamed lack of data, lack of satellites. Now I cannot say anything. There is no satellite data, everything is there. You cannot even figure it out. We are damaged. So this is something all of us think about. How come so much data available? So much analysis done. Why not even explain? Why did they get different things and other things? Now, I don't want you to July. We'll see what happens next month. So the month of July, we put the analysis for all July, the last 30, 40 years of good data. You know what it meant. You don't know what it is. Except 97, there is of course, and here is IoT is involved. IoT is still not, okay, I think I just have to figure. That's not have to figure. IoT is not yet, yeah, I'm sorry, I don't, IoT has no sign at all. As a matter of fact, last time I showed you there is a negative anomaly along the Somali coast to the Upperly, and then the positive anomaly along the Sumatra coast. Actually, it's a negative IoT, not positive right now. It may change, but right now it's not a positive anomaly. It looks like a negative anomaly. So the coastal regions of Somalia are cold, and coastal Sumatra shows a warm and quite warm. Okay. Thank you. So who is next week? Huh? Huh? Okay.
Jace, can I ask a question? Vishal here.
Sure.
Yeah, so actually my question is about the image you showed for pivot. And thanks a lot for actually reminding us about the variability in pivot. I was wondering your observation that dry pockets exist and they retain identity. That particular observation, is it only close to the Somali jet, or you think it's in general the feature of tropics?
I have to check because what we have to do is look at the, I'll ask Rajat to do it. Take that figure and put on top of it the jet position on that day, that is 5 days back. Let's see how close it is. Is it along the axis jet? I doubt it. I doubt that, but yeah, one should look at it. I think that PVAT animation should go along with the animation of, but one thing I tell you, that PVAT animation is very interesting. You know why? Because they use wind speed for that. I mean, it is done with wind speed. So, but you have to understand where the maxima of the jet is and where the PVAT anomaly is. But I don't think it is anywhere near the jet maxima, which is closer to, as I pointed out, it's closer to Karwar or somewhere. Jet is nowhere near that Kerala. Kerala is where that low PVAT is, right? We are nowhere near it, the jet. But what they can superimpose that and show that.
Right.
Actually, I would suggest somebody, I'm not able to do that. Somebody find out from that website how to download the data and do the animation more closely and see how it is. Data available, but I don't know how to get all the data. Okay.
Yeah. Thanks, Jace. Another comment is, I think you were mentioning about Hui Su. I have pasted the link to her paper which you mentioned. kind of ENSO link to OLR versus SST.
Yeah.
It's in the chat.
Huh?
I have
Who is that?
pasted the paper in the chat.
Okay, okay, good.
Yeah, thanks.
What's the name of the author? That's important. Huh? No, it's not Hugh. It is, I'll tell you, some other name. She's a woman, and of course, this could also be a woman's name, I don't know. But it is an American, not a Chinese name. Okay.
No. So she worked with David
I'll-
Nilin, Jace. She worked with Nilin, and
Okay.
it's a lady. So I was suspecting you are referring to her.
Yeah, that, I mean, the others may have worked, but this person is in either FSU or in Miami, one of these places, if I remember correctly.
Oh, I see.
I'll
Yeah,
go on and
she's
locate
in
it
Jet
and
Propulsion.
give
Yeah.
the email. Okay, yeah.
Okay. Yeah.
Okay.
Thanks.
Thanks.